Artificial intelligence is an invisible force embedded in our daily lives. It filters our communication, curates our media, and steers our cars through crowded intersections. Public anxiety usually centers on artificial superintelligence, a theoretical, monolithic entity capable of matching human cognition across every domain. Right now, we operate in the realm of artificial narrow intelligence. Systems like ChatGPT or facial recognition are incredibly powerful, but they are highly restricted, excelling only at single, specific tasks. To understand where this technology is heading, we have to look past the idea of magic and examine its structural layers. This concentric circle diagram shows that artificial intelligence is just a broad cultural umbrella term. To see how the engine actually works, we have to zoom into its technical subsets: machine learning and deep learning. Moving inward reveals that our future depends on mastering these specific algorithmic layers rather than fighting imaginary robots. Machine learning shifts how computers operate. Instead of programming explicit rules, we feed the machine raw data and let the algorithm learn. To identify a cat, it doesn't define a whisker. It processes labeled images to discover patterns, building a model capable of making predictions. Deep learning is the smallest, most complex inner layer of this architecture, an engine inspired by the human brain. Information, like image pixels, enters through the blue input layer nodes. That data flows into the green hidden layers, which extract complex features, moving from simple edges to fully realized shapes. Finally, the yellow output layer synthesizes those patterns to make a final classification. This intelligence is ultimately a highly organized logic engine, performing mathematical pattern recognition on a massive scale. Applying this deep learning architecture to text creates natural language processing. These tools can deduce emotion from Twitter trends or generate complete essays. Applying the same logic to visual data creates computer vision, allowing machines to detect shapes and contextualize their surroundings. In medicine, computer vision identifies anomalies the human eye might miss. These heat maps of brain scans show how AI can identify glioblastomas, a capability that reduces diagnostic errors by 30%. The same mathematical engine used for social media filters is now being used to detect disease and save lives. Algorithms are migrating from digital code into physical environments by combining with sensors and actuators to power modern robotics. Robotic systems like Boston Dynamics Spot use these algorithms to autonomously navigate and inspect unpredictable environments like construction sites. AI is also being applied to planetary scale issues, processing vast datasets to optimize energy use and predict extreme climate events like floods. AI has moved into high-stakes physical management, overseeing everything from industrial inspections to environmental disaster alerts. Because machines learn from patterns in human-generated data, they inevitably inherit and scale human flaws. One hiring tool used by Amazon taught itself to favor male candidates because it was trained on a decade of resumes submitted to the company. These systems raise unresolved questions about accountability, specifically who takes the blame when an autonomous machine makes a fatal error. These ethical and technical challenges are changing the job market, creating massive demand for new roles. AI specialists are projected to see 82% growth by 2030. Managing the learning systems already in operation requires an ethical and regulatory framework as robust as the technology itself.